So these are the set of topics we are going to cover. We are going to learn what AOP is for and why we want to use AOP. And we'll talk about the concepts and terminology of AOP and Aspect-J support in Spring. And then we are going to talk about types of advice and how we can declare those advices. And we'll talk about how to access so-called join points and declaring a join point, a point cut, and defining and using common point cuts, and then we'll talk about the concept of introduction. So many new terms, so we'll cover those terms as part of this presentation. What is and why AOP? We Java developers are pretty familiar with OOP design, OOP paradigm, object-oriented programming paradigm. It is pretty good in what it does, especially in usability and those object-oriented paradigms of inheritance and encapsulation and things like that. But in some cases, it makes code scattered in number of modules. For example, if you need to log, logging is actually one of the what is called the cross-cutting concerns examples that we typically use to explain the limitation of OOP. If you need to log for every method of every class, you have to actually add logging code in every class, and that is going to be pretty tedious work, and that code maintenance and update is going to be very difficult. So we need a different coding paradigm in those cases. So the issues of like logging example we just talked about is that code scattering, meaning same concerns are spread across classes and modules, meaning you have to add logging code in every single method of every single class. So the logging code is scattered everywhere. So that's one problem. Second problem is code tangling. So we use the term concerns. The concern is basically a particular functionality. So logging is one concern, security is another concern, transaction is another concern, caching is another concern. So whatever functionality that you need to have in your application is considered a concern. Now, without using AOP, so if you're using just OOP, we just talk about the problem of code scattering, but the second problem is code tangling, meaning many different concerns are kind of tightly coupled. So you're mixing up the code related to logging with code related to security, related to transactions. So many concerns are intertangled. So it's going to be pretty difficult to, again, maintain the code moving forward. Again, this is the reason why we need a different coding paradigm for this particular for this kind of situation. So AOP is born to solve that problem. So AOP addresses these issues we just talked about. So instead of adding logging code in each of the methods of every class, you specify which methods require logging applied and delegate the logging functionality to AOP container. So basically you're going to logically specify this is the logging code and I want to apply this logging code to my method that start with AOP as a name or something like that. Then it's going to be AOP container's responsibility to enforce the logging feature to a set of methods that start with a XYZ or ABC or something like that. So AOP container then calls the logging aspect of the code when the methods are invoked. So it's going to be a lot cleaner, meaning you have a logically single location to change your logging code. In previous scheme, in OOP only solution, whenever you need to change the logging scheme, then you have to go every single method and every single class to change it. But if you're using AOP, you have logically a single location to go and change, and that will be applied to every single method by the AOP container. Typically, you will see applications using AOP and OOP together. So the AOP complements object-oriented programming model by providing another way of thinking about the program structure. So aspects enable this modularization of concerns such as transaction that cut across multiple types of objects. So AOP will solve those two issues we talked about, scattering of the scattered code and also tangling of the code. Okay, it solved the problem by having a single, logically a single location to change, and it also solved the problem of the tangled code by modularization, by modularizing these concerns. Okay, so you will have you will have an AOP code that is relevant to security, and you will have the AOP code relevant to transaction. You will have AOP code relevant to logging, so they do not have to be tangled with each other. Okay, so in summary, AOP provides these benefits. It complements object-oriented programming paradigm and clean modular code without code scattering and code tangling problems we talked about. And the aspects can be added or removed as needed without changing your code. So your code remains the same, and if you add, for example, transaction, it basically you're going to add transaction aspect, and so your code does not have to change at all. Or if you want to remove it, again, it's a matter of actually taking that out, that aspect, transaction aspect, and again, your code does not have to be changed. The business object code is not tied to any specific API or framework, so this AOP can be applied without being tied up with any framework. All right, so let's talk about AOP terminology a bit. Okay. Cross-cutting concerns. So these are the functionalities that concern entire applications. So examples of these cross-cutting concerns, logging, transaction, security, auditing, logging, event handling, caching, and things like that. The reason it is called the cross-cutting concern is that these concerns are pretty much everywhere in your application. That's the reason it's called the cross-cutting concern. So whenever you have a cross-cutting concern, that's the time that you like to apply AOP. Okay. So transaction and logging and security, and these are great examples where AOP is being used. All right, so let's talk about the aspects. So aspects is basically a modularization of a concern that cuts across multiple objects and methods. Okay, so in AOP programming, basically you are going to create aspects, and we are going to see examples of these aspects definition in a few minutes. Concept of join point. So join point is a method in the execution of a program. So in general terms, join points examples include method invocation or exception handling. So this is the point in the execution of a program where you can actually insert your advice, so-called. In Spring AOP, however, the only join point that is used is method invocation. Okay, it's not going to use any other join point. The example is going to use just the method invocation join point. Okay, concept of advice. So advice is the code that gets executed at a particular join point. For example, you can execute an advice in a particular method whenever a method whose name starts with the XYZ gets called. Okay. Now the types of advice could be before advice, after advice, or around advice. So before advice is an advice. You can think of advice a fragment of code. Okay. This advice gets executed before join point, meaning before target method gets executed. After advice gets executed after join point, meaning after target method invocation is done. And around advice is around the join point, meaning before execution of the target method and after execution of the target method, you can do something about whatever you want. So that's advice. Again, advice, you can think of a fragment of code that gets executed before and after and around. Okay, point cuts. Point cuts is an expression that selects one or more join points. Okay, so so we're gonna actually see all these examples in a few minutes. Okay, so as long as you got the a big picture, that should be good enough. Okay, so the point cut, you are going to actually have some, it's almost like a regular expression type of expression that selects one or more join points. Okay, so you can say, I want to select set of methods that start with XYZ. As the beginning of the method name. Okay, I want to select all public methods and things like that. So those kind of things could be expressed and that is called the point cut. So by creating point cuts, you gain fine-grained control over how you apply advice to the components. Again, you can select whatever set of methods based on some conditions. As I said before, any method that starts with the XYZ as a name, any method that is public method or private method, any method that contains that receive a particular set of arguments and a particular set of types and things like that. Okay. Okay, so a typical join point is a method invocation, as I said before. In fact, in Spring AOP, this is the only join point that is allowed. Typical point cut is a collection of all method invocation in a particular class, or all method invocation that start with XYZ or ABC, things like that. Okay. So point cuts can be composed in complex relationships to further constrain when advice is executed. Okay, so you can actually build pretty complex point cuts. You can say, I want to select all the methods that start with the ABC, or I want to have all the methods that ends with XYZ, something like that. Okay, last concept is a target, and target is pretty straightforward. It's an object where you are applying those advice. It's an object where execution flow is modified by some AOP process. Okay, so they are sometimes called the object because you're applying your advice, fragment of code to that target. Okay, concept of weaving. So how you are going to insert these aspects into application code at the appropriate point. There are a couple of ways of doing this. One is at the compile time, and the other one is at the runtime. Okay, the last concept is introduction. So introduction is by which you can modify a structure of an object by introducing additional methods to it or fields to it. So basically, you can use introduction to make an object implement a specific interface without needing object class to implement interface explicitly. So let me actually rephrase this. And again, we're going to actually learn about this in detail later on. In Java, you have an interface and then you have implementation that implement that interface, meaning it will provide implementation of all the methods that are defined in that interface, right? Okay, and that has to be done at the compile time. By using introduction, you can add new implementation, meaning additional interface during runtime, okay? And you can actually add additional fields or properties during runtime as well. Okay, so that is introduction. Again, we're going to talk about this one in detail as a last topic. Okay, moving forward. So we just covered the concepts and terminologies of AOP. So let's talk about the Spring AOP capabilities and goals. So Spring AOP is implemented in pure Java, so there is no need for special compilation process. Okay, so compared to Aspect-J. So Aspect-J is it does have its own, let's say, AspectJ, the language, so that has to go through some special compilation. But Spring AOP is implemented in pure Java, so no special compilation is required. Meaning, you're going to write everything in Java. Okay, that's what we're going to learn in this presentation. Spring AOP currently supports only method execution join point, as we talked about. Okay, so there is no other type of join point in Spring AOP other than method invocation. So basically, method invocation, you're talking about the methods of Spring Beans. AspectJ support. So Spring could actually support the AspectJ. It does support AspectJ. So AspectJ refers to a style of declaring aspects as regular Java classes annotated with the Java annotations. So you can use the annotations, and that's basically what we're gonna do here. So use of AspectJ in Spring. Spring 2.0 interprets some annotations as AspectJ5. Using library supported by AspectJ for point cut parsing and matching. So AspectJ5, they actually introduced these Java annotations so that you can use AspectJ with Java. Okay, before that you had to use the AspectJ specific language. In Spring, so AOP runtime is still pure Spring AOP though, so there is no dependency on AspectJ compiler over Weaver as we talked about. So Spring AOP does not support AspectJ language as a default. Okay. However, you can actually still plug in AspectJ compiler if you want to, so that you can actually use AspectJ language in your Spring application if you want to, but that's usually not what we see. Okay. Okay, now in order to use AspectJ configuration in Spring, meaning this is basically the AOP support in Spring. So Spring AOP is actually dependent upon AspectJ, okay, the Java version of AspectJ, I would say. So you have to configure this AspectJ auto proxy in your configuration file. Okay, so here we define the namespace right here of AOP, and then we are going to say AspectJ-auto proxy. That means we are going to use the AspectJ as a scheme for supporting AOP. Okay, so now let's see how we can declare an aspect. So any bean that has aspect annotation will be configured with Spring AOP as an aspect. Okay, and if you want to get auto detected through auto scanning, you can also add component annotation. Okay, so if you have add component and add aspect like this, and this aspect object will be auto detected, and this will be configured. Okay, meaning the object instance will be automatically created by Spring Framework and will be used. Okay, so let's talk about the type of advice. So as we talked about, there is a before, after, and around kind of advice, right? And Spring AOP, it actually has a bit more fine-grained types of advice. So before advice is an advice that gets executed before a method execution. Okay. Now it does support now successful return and exceptional return and any return. So three different types of after advice. So after returning advice is advice to be executed after method execution completes normally, meaning successfully. There is no exception in the method. Okay. After throwing advice is an advice that gets executed when method throws an exception. Okay, so if the method exit through an exception, then this after throwing advice will be executed. After advice, or sometimes it's called the after finally advice, this is an advice that gets executed regardless whether method returns normally or exceptionally. Okay, so three different types of after advice and one type of before advice. Then it also supports around advice. So Run advice is again advice that surrounds a method invocation. So this is probably the most powerful kind of advice, okay? Because you can actually change the behavior of that execution before and also after, okay? It is also responsible for choosing whether to proceed to join point, proceed to the join point or not. So basically, in the before, it can, for whatever reason, it will stop the execution, okay? Or to shortcut the advised method execution by returning its own return value, or throwing an exception. So, the after execution of the target method, it might actually throw an exception if it wants to, or, it could actually return different value as a return value. So this is the most powerful advice. So what advice type do you want to use? So the rule of thumb or best practice guideline is use the least powerful advice type that can implement the required behavior. Okay. So for example, if you need only to update a cache with the return value of a method, then you are better off using after returning advice rather than around advice. Okay. In this case, around advice will accomplish the same thing, but you're basically wasting the power of around advice, okay, which means you are causing more overhead unnecessarily. So depending on what you want to do, if your goal is to do something before execution of the method, then you want to use it before. If you want to do something only after execution of the target method, then you want to use the after advice, okay, instead of using around advice. All right, so let's see how we can declare an advice. So advice is associated with point cut expression and runs before and after and around method execution matched by the point cut expression. Okay. So this point cut expression can be done in two different ways. The option number one is point cut expression declared right in place. And then option number two is reference to named point cuts. You can declare a point cut and then you can make a reference to it later on. We're going to mostly focus on option one for now, and later on we are going to actually see option two as well. But for now, we are going to talk about option one mostly. Okay, so this is before advice. Okay, so we have an aspect, so we use aspect annotation to indicate that before example is an aspect. Okay. So aspect will include a bunch of the advices. Okay, so here we define a single advice, which is a before advice. So we say at before, and this is the point cut expression. So what it means is that anytime the method whose name start with whose package is com.xyz.myapp.dao and any method after that. Okay, so we have a star dot star, and it doesn't matter what kind of arguments it's receiving. So, whenever any method under this package gets executed, regardless of the type of arguments and regardless of the return type, when that method gets executed, we want to do access check advice. Okay, so before these methods gets executed, this advice will be applied, and this is a before advice. Okay, so pretty straightforward, right? Okay, so within an aspect class, you are going to define a set of advices. Here we define only a single advice, and this is a before advice. And advice is the advice is defined with point cut expression. Okay, all right. So we're going to talk about option two later on. Okay, so for now we are mostly talking about option one, where you are defining advices right in place. Okay, this is after returning advice. Again, same thing. Anytime any method, any method of any classes that under this package get executed, I want to perform this advice, do access check, and this is after returning, meaning only when that method has been completed normally or successfully. So this is after returning advice. After throwing a device, the same deal. We just use the after throwing instead of after returning. And this is after returning, and this is after throwing. So this advice, do recovery action advice, will be only performed when a method threw an exception. Okay. Sorry about that. Okay, so that's after throwing advice. Now, after finally advice is, it will be executed regardless whether the method execution has been successful or not. Okay. Okay, let's talk about the around advice. So again, around advice runs around the matched method execution. Again, this is the most powerful the advice because you can do lots of things before and after. Okay. Now, the first parameter of the advice method must be the type of proceeding join point. So this is an object you can call to invoke the actual target method. Okay, so let's see an example of that. So this is an example of around advice. So we have an aspect, then we define an advice with around the advice. And again, this is a point cut expression. And then the actual advice should receive proceeding join point object. Okay, so you can actually perform whatever you want to before and after. In order to call the target method, you are going to use this proceeding join point object. So you're going to call proceed method of this proceeding join point object, and basically you are calling target method. Okay. And again, you can do whatever you want. Okay, so you might, in this case, we can just return the value that was returned from the target method, but we can return whatever we want. We can even change this guy. Okay, so that is the around advice. All right, so now let's do exercise, 3 exercises. Here we're going to do before and after and the around advice. So let's take a look at the hands-on lab. So exercise 1 is before advice. So basically you are going to, so before advice, so you are going to just run it. And this is a main method, you call it. And it will just display good morning. Yeah, so this is from a target, okay? And what we are looking for is before. So this is from the advice. So in the advice, we are basically displaying what is the target method and what are the arguments. Okay. So if you take a look at the code, I'm going to use the lab documentation. So we just did it. And basically in this code, we have an aspect. This is the aspect. So if you take a look at that aspect, so we define aspect, and we have a before advice, and point cut expression is that any method of the say hello method of greeting service, whenever greeting services say hello method gets executed, we want to perform this log before. Okay, so by the way, any aspect, the advice can actually receive the join point object. So join point object is actually representing the join point object actually. So you can actually find out the name of the target method. So you can say get signature and get name. That is in fact the target method. That's what you see here. Say hello. Say hello. Yeah, say hello, this guy. Okay. And you can also get the arguments. So here we are displaying the arguments as well. Okay. And this is the greeting service and greeting service implementation. And basically main code is, basically we get the application context from beans.xml file. Then we create a greeting service. We get the greeting service from the beans.xml file, and then we just call the say hello method. Okay. And if you take a look at the beans.xml file, we basically configure string AOP. Okay. And then we have to declare both your service object as well as we have to declare aspect bean as well, because it's just, its aspect is just another bean as far as the string is concerned. Okay. So 1.3 is modifying the project. So this is for your own exercise. So I want you to display the current date and time as well. Okay, using before aspect. Exercise 2 is after returning and after throwing. So this is actually after. So, basically, so this is, in this case, we are testing both after returning and after throw. Okay. So this is actually after throw. So, the normal operation. And this is, you can see this is the after failure, meaning the exception. Okay. So if you take a look at the code, we have defined the two advice. One is after returning, and the other one is after throwing. Okay, and so if you take a look at the greeting service implementation, we have two methods. Say hello. This is returning successfully. Say hello to, we are intentionally throwing some exception. Okay, so this target method will cause the after throwing advice, meaning this method to be executed. Okay, and so here we have to actually do try and catch, because we know this is actually throwing an exception. Okay, around advice is again, this is actually before and after. Okay, so if you take a look at the code, we have a single around advice in this aspect. Okay, and it received the preceding join point object, so we are calling it. Okay, so this is the business logic we'd like to execute before executing the target method, and this is the after a logic that we want to execute. Okay, all right, and the main code is pretty much the same. So here modify the project so that you check whether right now is actually noon or not. Okay. So if it is noon, you want to display good morning. If it is in the afternoon, you want to display good afternoon, something like that. Okay. All right. So I'm going to give you guys about 15 to 17 minutes. Yeah, I'll give you 17 minutes to try this exercise. Right. Next topic is multiple aspects and aspect ordering. You can certainly have multiple aspects for a target, and also you can specify the order of an aspect that could be applied to the target by using order, the annotation. So basically, you can say order and one. So the one aspect is going to be order one. The other aspect could be order two. So if those two aspects are applied to a same target, then they will be applied in order. And sometimes you need to make sure the aspects are being applied in a particular order. In that case, you can use order annotation. All right, so let me just explain this one, and we'll just move forward, and I'll give you a big chunk to the lab later on. So in this case, when you do the AOP ordering, so so it will be applied. The first one, this first aspect will be applied, then the second aspect will be applied next. Okay. So first aspect is specified with the order one. Okay, and second aspect is order two. So order one will be applied first, and then order two aspect will be applied next. Okay, and here you have to declare both aspects. Okay, for your own exercise, change the order. Change the aspect to be applied before aspect one. Okay, so that's your work. Now let's move forward with point guard designations, designators used in point guard expressions. Okay, so what are the point cut designators? So Spring AOP supports a set of AspectJ point cut designators for use in point cut expressions. The only point cut designator we have seen is execution, meaning when a target method gets executed, we want to apply our aspects. But other designators could be used. So let's take a look at each of these in a bit more detail. A target is to limit the matching to join points where the target object is instance of a given type. Okay, so you can specify I want to apply my aspect only when the target is a particular type. Okay, arguments, you can actually specify the arguments. So matching to limit matching to join points where arguments are instances of given type. Okay. So these are examples. Yeah, so these are execution point cut designator, and we have already seen these things. So this is a case that execution of any public method. So you see star star, and this is the execution of any method with a name beginning with a set, and execution of any method defined in account service interface, meaning package. Okay, and this is execution of any method defined in com.xyz service package or subpackage. So, in this case, you see ... here. So this is more inclusive than this guy. Okay. Okay. Within point cut designator. So within point cut designator, limits matching to join points within certain types. So here, any join point within the service package. And this one, any join point within the service package and subpackage. Again, see the ... Okay. All right. This point cut designator limit the matching to join points where the bean reference Spring AOC proxy is an instance of a given type. So basically, the join point itself has to be this type. Okay. And this is a target. So I want to apply our aspect only when the target is of this type. Okay. Arguments. So, basically the arguments has to be this type. Okay. So the point cut expression again can be actually designator could be actually pretty inclusive. Okay. Okay, so far we have looked into how you can declare an aspect with the point cuts right in place. Now we are going to actually take a look at option 2, where we are going to actually create a named point cut, and that named point cut will be used in some place else, meaning in some another Java file. Okay, so this is option number 2. So this is again useful when you want to reuse the same point expression. Okay, so in our previous option 1, point expression is defined in right inside the aspect. Okay, so it might not be actually be reusable in another aspect, so to speak. But if you want to create point cut as a named point cut, then that could be actually used someplace else. So you can create a named point cut and use it in several places. Okay, meaning several other aspects. A named point cut declaration has 2 parts. So you have to still have a point cut expression, and then you have to have a name. Okay, so this is the name that you are giving to that point cut expression. Okay, so in this case, this is the point cut expression, and the name is in a form of a method. Okay, so you are giving a name. The name is going to be any old transfer. That is a name. Okay, to this point cut, point cut expression. Okay, so declare point cut named any old transfer that will match the execution of any method named transfer. Okay, in this case, okay. So once you have defined a named point cut like an old name transfer, then you can use it in any other place. Okay, so for example, you can actually use this is another way um, creating or defining named point cuts. So here we are defining so-called any public operation point cut. Okay, so that's the name, and the point cut expression is this. This one is the point cut expression is this, and then we want to define it as in name. So that's the name of the point cut expressions. And then you can also actually define another one that actually using the this union. So I like to add point cut expression of this guy and this guy, and the union. Okay, so trading operation, the name point cut is combination this one and this one. Okay, all right. So it's actually pretty flexible. Defining and using common point cut definitions. So when working with enterprise applications, you want to refer to modules of the application and particular sets of operations from within the several aspects. So in this case, we are going to define what is called the system architecture aspect that captures the common named point cut expressions for this purpose. So let's take a look at an example. So we are defining system architecture aspect, okay? And then we defined several named point cut. So here we define point cut here, and we give a name to in web layer. And then we define the named point cut, and we're gonna call it in service layer, okay? So basically what we are doing is that we are creating collection of point cut the expressions, okay, named point cut expressions. We are defining in web layer, and we also define in service layer, okay, and then we also define in data access layer, and then in business service layer point cut, okay. So you're basically defining and this is the data access point cut. So this basically we defined an aspect in which it contains 5 named point cuts. Okay. Okay, and then what we can do is we can actually use that point cut expression by using this is the name of the class, and then we actually provide the name of that particular named point cut. So this is basically, in this case, system architecture is a way of organizing your named point cuts. Okay. So in system architecture, this is a collection of named point cuts that actually these guys are kind of relevant, right? Okay. So that is one way to organize your named point cuts. So if you happen to have many the named point cuts, you want to organize them into multiple, like system architecture or application architecture or something like that. Okay. Okay, so using named point cut definitions. The point cuts defined in such an aspect can be referred to anywhere if you need a point cut expression. Okay, so for example, to make a service layout transactional, you could write it in the following Spring context configuration file. So you can certainly so this is a way that you can actually provide some transactional behavior Spring application. So one way. So when you do provide a transaction, you can actually specify the transaction behavior in the context configuration file like this, or you are more likely to use the transactional annotation like this. So this is probably not the way you are gonna do transaction, but just to show that this is possible. So I actually specify the point cut like this, and then we basically have a transactional device and all that stuff. Okay. This slide, maybe I should actually remove it. This is actually adding more confusion rather than adding new understanding. So, okay, moving forward. Accessing join point information through join point. So this is something we have already done. Basically, whenever your advice is called, advice will actually receive a join point, and you should be able to access, the join point information. For example, name of the target method and arguments and things like that. So that's something we have already done. So log before join point, and you can get the name of the target method and arguments and things like that. So that's something we have already done. Okay, so we are going to actually do exercise 5 and 6, okay, which is basically exercising the things that we have learned up to this point, okay. So this one, this is actually the option 1, and exercise 6 is the option 2, okay. So in this case, point cut definition in same file, point cut definition in same file. So we're going to actually try this too, okay? So let's just run it. And this is what you should see, okay? And let's take a look at the code. So we are creating declaring the named point cut. So we are going to name it as logging hello, and then we are basically using that point cut here in this two advice, okay. Aspect 2, here we are defining another one. So in this case, we are basically, if you take a look at this one, it's the same, the target method. This is actually using say hello, and this is using say star, okay? So both of them will be applied when say hello method is invoked, okay? When there is a say goodbye method, then, this will be applied, but this will not be applied because this is a say hello, okay? So in this case, if you take a look at the main method, we are just calling say hello. So both aspects will be applied, okay? 5.3, you're going to actually modify the interface. You're going to have a speak something and speak something, and so see whether you can actually get this one displayed like this. Exercise 6. Now we're going to actually have a point cut definitions in a separate file. So basically we define the greeting service point cuts, and we define logging hello and logging to hello too. Again, this is say hello and say star in a separate file, and then we can actually use those these definitions in the right here, okay. So we can just use greeting service point cut class. That is a class, and then we can actually call logging hello method like this. So this is a way that we are basically reusing it. It actually enhances the reusability because we actually define it in two different in a separate file. Okay. All right. So that's your own project. Okay. All right. So I am going to give you guys about 15 minutes to do exercise 5 and 6, and 4, 5, and 6. Last topic is introduction. So introduction sometimes is called inter-type declaration in aspect J, allows objects to implement an interface dynamically by providing an implementation class. So it's like a configuring an implementation class for the interface during runtime. So instead of compile time, which we are familiar with, if you can have a multiple of those same effect as multiple inheritance as well. So in a way, this is a way that you can actually apply multiple implementations during runtime, and it's like having similar the feature like multiple inheritance. Why introduction? You don't need to modify the existing implementation in order to introduce new methods. Okay, so type of introduction could be adding new behavior, so adding new methods, or add new properties. Okay, so let's take a look at this. This is introduction declared as an aspect. So basically you have to specify declare parent, the annotation, in which you are going to specify this is a target implementation. And basically what you want to do is you want to add new interface and new implementation to this target class. So this is the new implementation, and this is the new interface. Okay, And we have another example here. So we this is the this is again same implementation, and we are applying. In this case, is a name, and this is a message. Okay, so we are applying another interface and implementation to the target class. So whenever target class method of this target class gets invoked, okay. Whenever this target class is used, you now can actually access this interface, the methods defined in this interface during runtime. So this is all done during runtime. Okay. All right. So this is the target class. The target class is basically displaying the greeting message. It will create a greeting message, and it will display it, and then it just return greeting. Okay. And this is the new interface. What we want to do is we want to reverse the message. Okay. And then new implementation, basically all it does is provide the reverse message method, and it will just reverse it. Okay. All right, so we're going to actually do exercise 7 for adding new methods, meaning new behavior, and exercise 8 is adding new state, okay, meaning it will add new properties. All right, so let's see that. Okay. Okay, so if you run add introduction behavior, so let's add introduction behavior. So you can see, yeah, I'm going to actually use the documentation. Basically, you can see things are reversed here, and it also display the reverse message and name. One is name, and the other one is the message. Okay, so we define aspect that has two declared parents. Okay, so this is the target class, and this is the new implementation and the new interface. So reverse name service import is going to the implement reverse name service interface. Okay. So here we define the reverse name service, the object, which is a type of this interface. Okay. And this is for message. Right, and this is new interface and implementation. This is for name, and this is for the message. Okay, and the main code. So we created a greeting service. Okay, and then we can just call we can just now we have a greeting service. Okay, which is actually applied. The introduction is applied. Now we can actually call the reverse name method. And here we are calling reverse message. Okay. And here we define all those bins. Exercise 8 is, here we are basically doing the same. It's a target class and new implementation, and now this is the interface. Now in our implementation counter service import, we basically we can add new properties. And then we have a getter and setter method. We have a getter method, and we can deal with that particular properties. Okay, so when we run it, it's basically count is incremented. Okay, all right. I'm going to give you guys just 3 minutes to exercise this 7 and 8, and then we'll move forward. Okay.